And before we go any further, it's totally worth a little bit of time to review some exponent rules. Okay, so how do we actually work with these things? Sometimes it's difficult to remember when we add them, when we multiply them, so on and so forth. Okay, so let me draw your attention to a new list over here on the left-hand side of the screen. And the first rule is when raising a number to a power, exponents multiply. All right, what do I mean by this? Well, examples are always good. So we've got x to the 10th. And let's say we want to take this value and square it. Okay, x to the 10th to the second. We've got two layers of exponents there. And the important thing is if we have a number, which is what we have in parentheses here, x to the 10th, and we want to raise it to a power, the exponents multiply. So in other words, the 10 multiplies by the 2 and we get 20. And so this is the same thing as x to the 20th power. Okay, pretty simple. Rule number 2, you can't distribute exponents to terms, but you can distribute to factors. Okay, so I'm going to beat a dead horse here. We had the example x plus y squared, right? We said this is not equal to x squared plus y squared. But if we had x times y, that was kind of crazy. If we had x times y in parentheses and we squared that, that actually is equal to x squared times y squared. Okay, so remember this. This is useful, and don't get these two confused. The reason I'm emphasizing this idea so much is that people get these two confused. You're allowed to distribute the exponent when the factors inside the parentheses are being multiplied, but not when there are two terms that are being added or subtracted. Okay, number 3, exponents add when multiplying two factors with the same base. In other words, maybe we have a number that's like 10 times an exponent, 10 times x squared, okay? And this we want to multiply by x to the 3rd. Okay, we've got a number 10, and then we've got two other factors in here, both with the same base. In other words, it's x to the 2nd power, and it's x again to the 3rd power. So when I say the base, it's the number that's being raised to the power. So in this case, these two factors have the same base, which is x. Okay. When two factors with the same base are being multiplied, you add the exponents. So 2 plus 3 is 5. This is actually equal to 10 times x to the 5th. Easy. All right. Fractional exponents are roots, rule number 4. Okay, so let's say we have the number 5 times x to the 1/2. Okay, x to the 1/2 is actually the same thing as the square root of x. So we could easily rewrite this as 5 times the square root of x. Or if we had a different number with like an even crazier fractional exponent, x to the 1/4 power, that's actually the same thing as the 4th root of x. In other words, the result of this value multiplied by itself 4 times, this value multiplied by itself 4 times will give you x. Okay, so it's kind of like a square root, but there are more multiplications going on. At any rate, that's what these fractional exponents are corresponding to. Negative exponents are inverses. We can take the fact that x to the minus 1st power is equal to 1 divided by x. Or we can take a slightly messier example, like maybe 5x to the negative 2nd, and we can use the fact that x to the negative 2nd is just the inverse of x to the 2nd. In other words, this result is the same thing as 5 over x squared. So negative exponents are inverses. Okay, hopefully these ring a bell for you guys. We'll definitely be using them in class.